So from our side, from EDIH Südwestfalen, I would like to welcome you all to today's webinar, which is about data preparation for artificial intelligence. Today, our moderator or our presenter is our colleague from University of Siegen, Sphesihle Ndlela, and she will introduce herself in some minutes. But without further ado, I would like to pass the floor to Jules to maybe also give some introductory words.
Yeah, thank you, Robert. Good morning to all of you. First note, we are recording these episodes. As you know, we have, this is the second of 5 episodes. The first one has been recorded, and we are making these episodes, these webinars available online. So just, follow up on us and you'll have access to it. So yeah, my name is Guilherme Pereira, and one of the co-coordinators of the Portuguese European Digital Innovation Hub called Attract. And of course, welcome to this series. It's just another joint initiative. These 2 European Digital Innovation Hubs are promoting together. We totally believe in boosting the innovation ecosystem throughout Europe, and doing so by bringing people together and entities together in a cross nations, cross Europe perspective. So of course, both our European Digital Innovation Hubs' goals and mission is to promote the experimentation and testing and development towards the adoption of AI and high performance computing solutions in order to obviously transform our society and economy. We totally believe in what we're doing, and we totally believe in doing it by sharing best practices and telling you stories about how easy we find that adopting such solutions to our organizations is, and the tremendous added value to it. Of course, there are a lot of buzzwords around this. Artificial intelligence, everyone's talking about it, and most especially generative AI most recently. And we believe that by launching this webinar, this web series on Gen AI, we believe that we'll be sharing very good, easy to understand, easy to share, easy to talk about expertise and knowledge. And we'll do it by highlighting some 5 specific topics which compose the agenda of the 5 episodes. So for us, from Portugal, it is a pleasure to be here with you guys, our colleagues and team from the Südwestfalen EDIH, and it's obviously a pleasure to have people on board with us. And this is just yet another initiative of the several initiatives we're launching. Pleasure to be here with you guys, and I'll pass on the word to Spi, which will lead today this episode. Okay, we'll be seeing you in a couple of weeks' time for sure again. Thank you very much.
Thank you, Juliana. I will share my screen quickly. Just let me know if you can see it.
Yes, see perfectly.
Cool. So I'll be starting. Good morning, everyone. My name is Sphesihle Ndlela. I am a software developer. And today I will be sharing data preparation and cleaning. So maybe a bit about myself. I am a software developer, as I've said, and also I've been a developer for almost over 15 years, but currently I'm a researcher at University of Siegen. So my research interests data science, data integration, enterprise integration, business models, and I've done some bit of work on SME management in terms of longevity, transformation, and cognitive managerial capabilities. So the agenda for today, I want to keep it short. I will focus on just 3 concepts. This is a very big concept, but I'll try and highlight the common themes or critical concepts that could maybe help you in your businesses. So I'll start off with the usage of generative AI and also in industry adoption. So rapidly, generative AI is growing, and it can generate images, text, responses, music, and other files by training the huge amount of data. The applications are built on top of large language models, and the large language models are built on publicly available data, for example, ChatGPT. But that does not stop organizations not to use their own data to leverage on this technology. Organization can borrow the existing model alongside their data or create their own LLM from scratch. So I had a look at industry adoption. There was a research that was conducted in Germany. By the look of things, it shows that we are indeed in a digital transformation era, and generative AI is rapidly covering its niche in the global market. So it drives the creation of unique, high-quality content, simulating human language, and designing innovative products. So as you can see in this graph, we can see that marketing in Germany is the one that has the highest score or the highest percentage in adoption, followed by product and IT. And also just to highlight that 35% they're integrated in processes, 41% they use regularly, and 16% use rarely, and 8% not yet used. So it shows that this is a growing field. So I'll talk about LLM and data. Where do generative AI models get the data to process? It gets the data from unstructured, semi-structured data, the data that can be organized in databases such as email, PDFs, text, call center recording, chat logs, and videos, etc. Also can get the data from information such as HTML, which is defined in data fields such as HTML, XML, CSV, and etc. Or it can also get the data from data like spreadsheet or defined database fields such as sensor data, CRM, or ERP. So I'll just look at maybe a synopsis of how this data is extracted. Let's say, for instance, you're getting data from the SQL, you have to establish the connection. The data is extracted then into and saved into semi-structured formats such as CSV, JSON, XML, and then you process the data into the format like JSON or any other format expected by the model. And then you pass the formatted file into the model and process. So let's look at LLM business applications. I'll look at the characteristics, LLM types, ensuring data quality, and I'll just give some few business examples. So the characteristics of the LLM, they are enormous neural networks with billions of parameters. These parameters help the model to understand and generate text. And also they are trained on diverse, extensive data set, including books, articles, websites, and other sources. And also its capabilities, it provides some extensive problem-solving capabilities that can be applied to fields like healthcare, finance, or even entertainment, where LLMs serve as a variety of natural language processing application, such as chatbots, and AI assistant, and so forth. So we can then all agree that generative AI actually use data, so it is important to make sure that you have the quality data. So the quality of your data will impact the performance of your model, and the quality of data fed into the model, it must be accurate, it must be relevant, complete, and it must have no bias. So basically, it's garbage in, garbage out. So the generative AI models are therefore as good as the data at which they are trained. So let's look at the cross-industry standard process for data mining. This process helps with assessing the maturity of the data in the organization, because a good project starts with the deep understanding of the customer's needs. So in a nutshell, this process will ensure the data quality produced for the models. So this starts off with business understanding, understand the challenge and its context first, and then you can design the business objective. So check the availability of data, and for the problem that you're trying to solve, you collect the data, and then you go to data preparation, you select the data, you clean the data, construct the data, integrate quality. And then you go to selecting the model and you generate test design, you build the model, and then you assess the model. And then you go to the evaluation process and you review the process to determine further steps such as deployment plan, you plan monitoring, you produce final reports and review your project. But for this presentation, I will just focus on these 4 pillars. But let's start off with looking at LLM types. We've got prompt engineering. So this is a process where you guide LLM to generate output. You can choose the most appropriate formats, phrases, and words that will guide the LLM to interact with your users more meaningfully. So the prompt engineers bridge the gap between your end users and the LLM. And then we've got retrieval augmented generation. It's known as RAG. It's a technique for enhancing the accuracy and reliability of the Gen AI with facts fetched from the outsourced sources. Users can have conversation with data repository, and also it allows the organization to use their internal data and external data sources. For instance, the medical index could integrate with the doctor's system, and the financial financial analysis system would benefit from the assistant linked to market data. So you can also train a model from scratch. You design and develop a new model from a data set using transformers and tokenizers. And also we've got fine tuning. You're leveraging knowledge of an existing model that has already learned and as a starting point for new task. So I'll just focus on the 3 highlighted for business cases. Let's just go further in the prompt engineering. The prompt engineering is the process where you construct instruction and can be interpreted and understood by the generative AI model. It helps to best formulate the instructions or prompts to get the most helpful answers from the Gen AI model. The general principle is the better the prompts, the better the results. Therefore, prompts can act as a basis of interaction with generative AI tools to get better results for certain tasks in an organization for efficiency. So let's look at the sentiment analysis tool for today. So this tool is pre-built that detects positive or negative sentiment in the text data. You can use it to analyze social media, customer reviews, or any text data that you are interested in. Giving the text and accompanying labels, a model can be trained to predict the correct sentiment. The label can be positive, negative, or neutral, or could be predefined. So let's look at the customer service ticket. So a company wants to use a generative AI model that will classify customer support looked by customers into categories such as account, technical support, inquiry, and billing. The first task will be to clean the data so that we are able to create the effective prompt for the model. The company uses CRM data as a storage. So you collect support ticket from a database stored in tabular format, like a table in the database. So that's just a business understanding. Please note that as we go along, I will actually be pointing out also the process of data mining. So the high level of the sentiment is the expressed sentiment in text X is Y, and then you pass it to a large language model, and then it comes back with a label for you. So the model searches for a token Y based on the trained parameters on the text in location X. It maximizes the probability of the mask token in location Y. So what do I mean? If a user sent my computer is not working via the LLM, the category will be technical support. If the user says, please send me billing invoice, it goes via LLM, and then you come back with the category billing. So for this example, these are the tools. I actually used VS Code, I used Python, and I used some open source Python libraries that contains multi-dimensional arrays and data structures, which are easier and efficient to use when you're cleaning your data. So this is the data that is extracted from CSV file, but we are interested in the ticket description. That's what we will use to create a prompt. So then we have to remove the unwanted and duplicated data. You obviously you import your libraries, you load the data to the data frame, you refine the data set with rows that will contain billing, invoice, computer, Wi-Fi, internet, and account, and so forth for the from the ticket description. So you also identify and remove the duplicates to ensure that each data point has its unique, each data has a unique data point, and you save the new data and clean data set for a final test. So after that, I've loaded the data, you clean the data set, you load the clean data set into a data frame, you keep the required information for categorization, you create an extra categorical column for sentiment categories. This will be used in the prompt. So as you can see, testing this, I actually use an open AI model, ChatGPT 3.5 Turbo. So you can see that we have constructed the prompt using the data that comes from the database. So basically then you then tell the LLM that you will be given a list of customer service categories and a series of customer support tickets. Your task is to classify each ticket into one of the following categories. And then you give the prompts, the billing, the technical support, and then you give it the information that you took from the database. And you then now test the user input. So when the user says, please update my email from email X to email Y, then this is the user query, and then the prompt, this is what you give the prompt, and then the assistant or the response will come back with the correct category, which is the account. And I did the same test with the billing, and it came back with the user mimicked the user to say, please process my invoice, and it came back with the bill with the billing category. And the last test that I did was for general inquiry, because it had said, please assist, I have a problem with the product purchased. And then I did the test, I have a problem with the product X, and then it came back with the correct category. Right, so let's move on to RAG. Retrieval augmented generation, how does it work? So RAG was developed to link LLM services to external sources. So it extends the already powerful capabilities of LLM to specific domains or organizations with an internal knowledge base, all without the need to retrain the model. So the goal is to search and merge relevant context from the data set into the prompt fed into the model at the generation time. It redirects the LLM to retrieve information from the authoritative predetermined knowledge sources. Let's look at the business case example. Let's say a portfolio manager at the financial company approaches you as a data scientist. They require you to check the recent information about the stock of Apple. The company has some historic data in the local database with the related information, but wants to verify if it is correct. Then you want to verify closing and adjusted prices and volume of stock traded on a particular day for a portfolio report. So this is the high level architect or design. This is the data, maybe that your data might be coming from as structured or unstructured or even API from outside. and then you store it on your local database, and then you take the information that is in the local database, you embellish it with query and with the relevant data, you send it to the LLM and it gives you the response. So you have your historical data, you load the data set with the list of stock from the database, you create the query prompt with the relevant data and prompt. But the first thing that you need to do, obviously, is to clean data first. Same process I followed. You load the historical data to the CSV file, extract the information for the stock in question, clean the data with empty rows, and then you remain with the data set that you could use. So you prepare the prompt and send it to the model. So what was the closing price for AAPL, which is Apple, on the particular day? So your prompt will then instruct the LLM that you're a financial advisor who is helping a portfolio manager to get a closing or adjusted prices and volume of trades for a particular day. You use the information, you use this information when answering. So this is the information that is already stored in the local database. So because we want to verify if this information is correct. So you pass this into the LLM, and then it will come back with the closing price was this amount, the adjusted price was not provided, the volume of trades for this stock was on this particular day was this number. So basically what happened is you actually embellished the prompt, the user query, and the relevant data into the database, and then you got the response with the data that comes from the reliable source. Same thing, I use an OpenAI model and ChatGPT 3.5 Turbo to test. Let's look at training a model from scratch. The LLM high level, this is just a general one that I had to come up with just maybe for a better understanding. So LLM is data plus transformer plus training the data. So what the transformer does, it's a neural network model that learns the context of sequential data and generate new data out of it. It handles the sequences of data, considers every word in sentence in relation with other words. Hence, cleaning of data is important. So I would just look at the concept of data when creating a new model, a new model from scratch. And I put the note here. Please check the architecture of the transformers, maybe for better understanding after this. So these are the building blocks of the LLM: is tokenization, text sequences undergo division into smaller units or token, and then there's embedding. It's a vector representation of tokens that capture the semantic of information. Vectors encode the intricate relationship between the tokens. Attention, it analyzes the relationship between all tokens in a sequence. Also, the pre-trained model become repositories of the large language expertise. It mimics the human-like language use. The pre-trained model adapts to new tasks without needing to retrain from scratch, which is transfer learning. So let's just look at the general or common practices. If you get the data maybe from CSV or from anything that is tabular format, you would want to remove the unwanted data. You want to remove the duplicates. You want to remove or imputate the missing fields. So you ensure quality. Imputation is taking a calculated value and inputting it into a missing value, and all this depends on what model and what are you doing with your data. And you remove instances where there is more than one record. Let's look at the common practices for noise reduction and techniques in the text. We have tokenization, converting sequence of text into smaller parts, and removing stop words and punctuation simplifies the dataset, reducing complexity and allows model to focus on the semantic context of the text. Handling errors is crucial because it improves accuracy and text processing of the application. If the errors are not handled, then it can lead to an unsatisfactory result for the entire project. Dealing with noise, you fix the label in the text. For an example, in the sentiment analysis category that contains mixed examples. So you must make sure that the labels are correct, for instance. Transforming text into a single canonical form, that is text normalization, is just a separation of concern and grouping the related text. And there's a stemming process, producing the root of the base word. For instance, running, would save it as run without the knowledge of its context. And then we've got lemmatization, the process of grouping together the inflected forms of words so that they can be analyzed as a single item. For instance, like the use of vocabulary. So the conclusion for today that maybe that we should take away for today is that data cleaning comes in all shapes and sizes, and there is no one template to handle all situations. As a data scientist, given a problem, you must keep asking questions from the right team and experiment those questions deeper to be able to give business meaningful model. And also, lastly, before you bring data into a model, make sure that it is clean, it is consistent, and it is accurate. This is the end of my presentation, and thank you so much for attending, and thank you so much for listening to me. Thank you.
Thank you, Spi.
Okay, yeah, Spi, thank you very much. And now we have, of course, the time, as always, to answer some questions. So if you have any questions, just feel free to ask them.
Robert Spi, let me just ask you something which I believe I know the answer for, but we can share this presentation with a group of people that are attending the different episodes of the series. Spi?
Yeah, Robert, yeah, I don't have a problem.
Yeah, of course. So when it's okay from your side, we can share it, yeah.
Because I found it very simple and agile, in meaning that it's very clear to follow through the whole presentation. And we're in such a hype of Gen AI, and everyone's talking so much about it, and we listen to it all the time, and we attend so very many different presentations. But Spi, I think you live it you put it in a very clear way. The whole step 1, 2, 3, 4 throughout till the end. Very simple to follow through, very simple to understand, and you can actually realize that these are tools for us all to use, regarding different aspects and say rules, if you want, and bearing in mind that these models are probabilistic, not deterministic. So if you follow through, your presentation, it's very easy to understand the good use that we can make of it. So I like the presentation very much. I didn't know it in advance, and it fits perfectly in our series. So I would thank you, and I see it again as a very useful tool to be shared. Of course, we don't have a lot of people with us today, but I think the whole set of documents that we are to share throughout this series should be very interesting to be put in one, slide deck and made available to the community.
Sure. Thank you, Jeremy.
Okay, are there any further questions?
Doesn't look like it.
Okay, if not, we can, of course, also end it here. We will have the third episode of our webinar series in 2 weeks, same time, but not delivered from EDI Südwestfalen. It's the first time that EDI Attract will deliver that series.
Yep.
I think I also speak for Guilherme. We are very happy if we could welcome you there as well. And I will pass the floor to Guilherme to maybe close the session, but it would be great if we see you again in 2 weeks.
Well, yeah, I mean, just very, very short ending of the session. Again, Gen AI is under such a hype, and there are so many events, talks, conferences, all overlapping our agendas. Even today, we are having an event in the Madeira Islands. We're brought together a set of European digital innovation hubs, and of course, Gen AI is going to be on the agenda of the conference, so to say, with a specific slot. So, although these topics are being spoken about and explained all over all the time, people in general and organizations in general are not there yet. We are not taking advantage of this, and this is here for us to use to take the best out of it. So, reason why we insisted on bringing this topic to this web series. This was just the second episode out of 5. We will be sharing the recordings, the presentations, etc. And of course, we look forward to have you with us, as Robert was saying, in 2 weeks' time, and then again in 2 weeks' time for the 4th episode, and we'll wrap it up all together on a 5th episode. That's it for today, Robert. I think we'll be communicating and spreading the word on what we have ahead, sharing what we have had in the past, and totally convinced that we got to do this more and more and more and more. Thank you, guys. Thank you, Sphee, for a fantastic presentation, and I'll see you soon for sure.
Thank you.
Okay. See you. Thank you very much. Bye.
Bye.
Bye. Thank you.
Bye. Thank you.
Bye.